Hi, welcome to the next section, Creating Great Maps. In this section we'll cover the important features that enable us to create great maps. We'll first go into advanced vector styling, then we'll learn how to label features, as well as more advanced road labels with road shield graphics. We'll also tweak labels manually. Then you'll get to know the print composer and use it to create printable maps and map books. Finally, we'll explain how to create web maps directly in QGIS to present our results online. Now we move on to the first video of this section that deals with advanced vector styling. In this video, we're going to create detailed custom visualizations using different types of styles like graduated styles, categorized styles, and so on. So let's start our journey by creating a graduated style. Graduated styles are great for visualizing distributions of numerical values in choropleth or similar maps. Let's load our sample data. Go to Layer, and Add Vector Layer. Now browse the files and select the climate.shp file that contains locations and mean temperature values. Once the layer is loaded, double-click on it in the Layer panel to open the layer properties. Now, go to Styles and select Graduated from the drop-down list. Now the graduated renderer supports two methods, color and size. The color method changes the color of the feature according to the configured attribute, while the size method changes the symbol size for the feature according to the configured attribute. So in the climate.shp file that contains locations and mean temperature values, we can visualize this data using a graduated style by simply selecting the TF mean value for the column field and clicking on Classify. Here we'll change the precision to 1. You can make the preferable changes and click on Classify. Using the color method, we can pick a color ramp from the corresponding drop-down list. Additionally, we can reverse the order of the colors within the color ramp using the Invert option. Graduated styles are available in different classification modes. The first option we have with us is Equal Interval. This mode creates classes by splitting at equal intervals between the maximum and minimum values found in the specified column. Next, Quantile or Equal Count. This mode creates classes so that each class contains an equal number of features. Third one, Natural Breaks or Jenks. This mode uses the Jenks natural breaks algorithm to create classes by reducing variance within classes and maximizing variance between classes. Then comes Standard Deviation. This mode uses the column's values standard deviation to create classes. And the last one, Pretty Breaks. This mode is the only classification that doesn't strictly create the specified number of classes. Instead, its main goal is to create class boundaries that are round numbers. For now, we leave it as it is. We can also manually edit the class values by double-clicking on the values in the list and changing the class bounds. Let's close this dialog. A more convenient way to edit the classes is the histogram view. Switch to the histogram tab and click on the Load Values button in the bottom right corner to enable the histogram. You can now edit the class bounds by moving the vertical lines with your mouse. You can also add new classes by adding a new vertical line, which you can do by clicking on an empty space in the histogram. Besides the symbols that are drawn on the map, another important aspect of the styling is the legend that goes with it. To customize the legend, we can define legend format as well as the precision that should be displayed. In the legend format string, 1% will be replaced by the lower limit of the class, and 2% by the upper limit. You can change this string to suit your needs, for example, to this, from 1% to 2%. If you activate the Trim option, excess trailing zeros will be removed as well. When you use the Size method, the dialog changes a little, and we can now configure the desired symbol sizes. Now let's apply the changes and click OK. So you can see the results of using a graduated render option with 5 classes using the Equal Interval classification mode. The left-hand side shows the results of the color method, that is, symbol color changes according to the TF mean value, while the right-hand side shows the results of the size method, or we could say symbol size changes according to the TF mean value. In this example, we use an existing color ramp to style our layer. Of course, we can also create our own color ramps. To create a new color ramp, we can scroll down the color ramp list to the new color ramp entry. There are 4 different color ramp types which we can choose. Let me show you each one of these. Go to Settings and then to Style Manager. So these are the existing color ramps. When you click on the plus button, you will have all different color ramp types available for you. The first one here is gradient. With this type, we can create color ramps with 2 or more colors. The resulting color maps can be smooth gradients, which you can obtain using the continuous type option. Or it can be distinct colors using the discrete type option. When you keep it continuous, you'll have the color ramp without relative position. And when you change the type to discrete, you have the option to vary the relative position as you like. Let's keep it as continuous and save the changes, and click OK. You'll be asked to give a name to the color ramp. We give the name for this one as New Gradient Color Ramp. Now you can see that it's been added to our existing color ramps. The next type is random. This type allows us to create a gradient with a certain number of random colors. Then the third one, Color Brewer, provides access to the Color Brewer color schemes. And the last one, CPT City, provides access to a wide variety of pre-configured color schemes, including schemes for topography and bathymetry, as you can see here. You can select any of these. When you click on OK, you'll be asked for a name. We go ahead with the default name. You can now see that this one has been added to the existing color ramp. Here you can add, delete, edit, export or import color ramps and styles using the corresponding buttons on the right-hand side of the dialog. Just as graduated styles are very useful for visualizing numeric values, categorized styles are great for text values or, more generally speaking, all kinds of values on a nominal scale. A good example for this kind of data can be found in the trees.shp file in our sample data. So let's load this file. Browse the Shapes File folder and select the trees.shp file and load it. Double-click on the Trees layer in the Layer panel, and when you're at the Layer Properties dialog, go to Style and change the style to Categorized. Now for each area, there is a veg desk value that describes the type of forest found there. In the column drop-down, select Veg Desk. Using a categorized style, we can easily generate a style with one symbol for every unique value in the Veg Desk column. We'll choose a color from the list, say green, and change the symbol color as well. Done. Now we're ready to click on Classify and OK. Once we click on OK, the style is applied to our trees layer in order to visualize the distribution of different tree types in the area. Of course, every symbol is editable and can be customized. Just double-click on the Symbol Preview to open the Symbol Selector dialog, which allows you to select and combine different symbols. Now let's move on to learn creating a rule-based style for road layers. With rule-based styles, we can create a layer style with a hierarchy of rules. Rules can take into account anything from attribute values to scale and geometry properties, such as area or length. Here we'll create a rule-based renderer for the ne_10m_roads.shp file, which you can download from www.naturalearthdata.com. As you can see here, our style will contain different road styles for major and secondary highways, as well as scale-dependent styles. Let's first load the layer. As you can see, the files which we downloaded are placed in the Shapefiles folder. Load the ne10m_roads.shp file. Once the layer has been loaded, double-click on the layer in the Layer panel and go to Style and select the styles as rule-based. Let me delete the previous rule and let's add a new one. On the first level of rules, we distinguish between roads of type major highway and those of type secondary highway. Let's enter the label as type equal major highway and set the filter as the same. Now we can even test it. It returns the number of features available. The next value of rules handles scale dependence. To add this second layer of rules, we can use the Refine Selected Rules button and then select Add Scales to Rule. For scale refinement, we need to have a symbol. Let's go to Edit Rule and add a symbol. Make the changes. OK. Similarly, let's do this for secondary highway. Give the label and filter. Now refine the rules, and after this, give the scale values. Now let's go to Edit Rule and add the symbol group. Now let's apply and click on OK. Now you can see the rule-based renderer and the scale rules in action. Our map now shows the major highways and the secondary highways. In these examples, we created categories or rules to define how features are drawn on a map. An alternative approach is to use values from the layer attribute table to define the styling. This can be achieved using a QGIS feature called Data Defined Override. These overrides can be configured using the corresponding buttons next to each symbol property, as described in the following example. In this example, we'll again use the ne10m_roads.shp file from Natural Earth. So let's load the layer. Go to the Shapefiles folder and select the file. We'll set the configuration to create a style where the line's pen width depends on the feature's scale rank, and the line color depends on the toll attribute. So, to set a data-defined override for a symbol property, you need to click on the corresponding button, which is located right next to the property, and choose Edit. Let me enlarge this dialog. The following two expressions are used. Now, let's write the expression. Case when toll equal to 1, then red, else light grey, end. This expression evaluates the toll value. If it is 1, the line is drawn in red. Otherwise, it's drawn in grey. Click OK. When data-defined overrides are active, the corresponding buttons are highlighted in yellow with an epsilon sign on them. Now, edit for the pen width. Let's write the expression 2.5/scale rank. This expression computes pen width. Since a low scale rank should be represented by a wider line, we use a division operation instead of multiplication. Now click on OK, and you can see that this is active as well. Let's apply the changes and view our map. Awesome. Let me zoom in. In this example, you've seen that you can specify colours using colour names, such as red, gold, and deep sky blue. Another especially useful group of functions for data-defined styles is the colour functions. There are functions for these colour models. Now the light grey is not clearly visible, so let's change the colour. Change the expression again. This time we put blue or yellow instead of grey. Let's go with yellow. Now it's quite visible. In Section 4, Spatial Analysis, you learned how to create a heat map raster. However, there is a faster, more convenient way to achieve this look if you want a heat map only for displaying purposes, and not for further spatial analysis. This could be done with the Heat Map Renderer option. Let's do a heat map renderer setup for our populated places dataset, that is, pop.shp. You just need to double-click on the layer and go to Style and select Heat Map. You can specify a colour ramp that will be applied to the resulting heat map values between 0 and the defined maximum value. If maximum value is set to automatic, QGIS automatically computes the highest value in the heat map. As in the previously discussed heat map tool, we can define point weights as well as the kernel radius. The final rendering quality option controls the quality of the rendered output with coarse, big raster cells for the fastest option and a fine-grained look when set to best. Let's apply the changes, and here we have generated a heat map. Cool! Now let's step ahead to take our hands on an amazing task, that is creating a 2.5D style. If you want to create a pseudo 3D look, for example to style building blocks or to create a thematic map, try the 2.5D renderer. The shapefile which we are using here could be found at github.com by browsing this URL. Once you've downloaded the files, you need to extract the files, and we've placed these in the shapefiles folder. Here we have the buildings.shp file. Let's go to Add Vector Layer and load this file. Now, when you have the shapefile loaded onto the map, go to Styles and change the type to 2.5D. Here you'll see the current configuration options and include controls for the feature's height. Let's change this to 1.2 and the viewing angle as 70 degrees. Since this renderer is still being improved, you might find additional options in this dialog when you see it for yourself. Let's apply these configurations to the layer and click OK. Superb! Once you've configured the 2.5D renderer to your liking, you can switch to another renderer to, for example, create classified or graduated versions of symbols. Now we can also add live layer effects to our map. With layer effects, we can change the way our symbols look even further. Effects can be added by enabling the Draw Effects checkbox at the bottom of the symbol dialog. To configure the effects, click on the star button in the bottom right corner of the dialog. The Effect Properties dialog offers access to a wide range of effect types. Let me tell you what each one of these does. First is Blur. This creates a blurred, fuzzy version of the symbol. Next, Colorize. This effect changes the color of the symbol. Source is the original unchanged symbol. Drop Shadow creates a shadow. Inner Glow creates a glow-like gradient that extends inward starting from the symbol border. Inner Shadow creates a shadow that's restricted to the inside of the symbol. Outer Glow creates a glow that radiates from the symbol outwards. And the last one, Transform. This effect can be used to transform the symbol. The available transformations include Reflect, Shear, Scale, Rotate, and Translate. We'll just select Drop Shadow. Also, we can combine multiple layer effects, and they're organized in effect layers in the list in the bottom left corner of the Effect Properties dialog. Let's change the offset value and increase the transparency, and click on OK. Fine. Now, before we end this video, let's see how to work with different styles. When we create elaborate styles, we might want to save them so that we can reuse them in other projects or share them with other users. Wait, I'll show you how to do this. Let's go to Style. We'll change the symbol and we'll render the airplane style. Apply this and click on OK. Layer type. Now, to save this style, click on the Style button in the bottom left corner of the Style dialog and go to Save Style and then click on QGIS Layer Style File. This will create a .qml file, which you can save anywhere, copy and share with others. Similarly, to use the .qml file, click on the Style button and select Load Style, and it will be loaded onto your map. You just need to give the file name and proceed further. We can also save multiple different styles for one layer, for example for our airports layer. We might want one style that displays airports using plane symbols, and another style that renders a heat map. To achieve this, we can perform a few simple steps. First of all, configure the plane style. Here it's already configured. Now click on the Style button and select Add to the current style to the list of styles for this layer. After this, in the pop-up dialog, enter a name for the new style, for example, Planes. Add another style by clicking on Style, and then Add, and call it Heatmap. Now you can change the renderer to Heatmap and configure it. Click on the Apply button when ready. In the Style menu button, you can now see both styles, Heatmap as well as Planes. Changing from one style to the other is now as simple as selecting one of the two entries from the list at the bottom of this menu. Click on Apply and OK, and you can see it's changed to Planes as per my selection. Finally, we can also access these layer styles through the Layer context menu. Styles entry in the Layers panel. This context menu also provides a way to copy and paste styles between layers using the Copy Style and Paste Style entries respectively. Furthermore, this context menu provides a shortcut to quickly change the symbol color using a color wheel, or by picking a color from the recent colors selection. You just need to right-click, go to Styles, and here you can find the options Copy Style, Add, Remove, and Rename. It was quite a long video, but I'm sure you enjoyed it, and now you're loaded with tons of skills to play with maps. In this video, we successfully created many custom visualizations.